A little bit about me before I get started. I do freelance developer relations. I'm originally from the United States, so I'll be speaking in English today for obvious reasons. I've been traveling with my family around Europe for the last 2 years, and so we're living in Scotland right now. I do performance audits, so I help companies test their websites and their native apps to see if they can be sped up. And I run workshops on performance, how to optimize images, how to optimize video. I wrote a book on how to identify issues in Android apps, and that's the link to the PDF. So if you're interested, you can just download it from there. I'll post the slides up later so you can get those URLs as well. If you ever have any questions about app performance, did it go out? Oh no, it's back. All right, awesome. If you ever have any questions, I'm the only Doug Sillars on the internet, so I'm really easy to find. But before we start talking about app performance, how many of you get nervous thinking? I'll just speak loudly. It's coming in. It sounds like it's coming in and out. We'll figure it out. All right. How many of you get nervous thinking about walking across this walkway that's nailed into the side of an Alp? Anyone? Right? Yeah, it's pretty terrifying. A lot of people are afraid of heights. And I walked across this with my family, and my daughter, who was 6 years old at the time, decided to jump the whole way. So it had this nice rattling effect going on as well, which was really, it added to the ambiance. But Ericsson 2 years ago did a study where they attached sensors to people's whether or not different stress levels to different responses. Line made people add people's stress level. They found that standing on a cliff raised people's stress responses. It stressed them out. But interestingly, they found out that a slow mobile experience is actually more stressful than standing on the edge of a cliff. So, feeling you all had about 45 seconds ago about thinking about standing on the edge of a cliff, if you have a slow mobile app, your customers are feeling that same experience. And we all know that when people are frustrated or they're feeling nervous, they're not happy. And we want people to be happy because when people are happy, they buy more stuff or they come back and they use your app more often. And we all know how hard it is to get app engagement. So it's important that we have a fast mobile application. But then the question is, what's fast? How do we know what fast is? And it's really hard because fast is really a human perception. And so there's some research done on this, and 100 milliseconds is perceived as instantaneous. And actually, that's 100 milliseconds, right? Where it goes from one to the other. That's 100 milliseconds. So we feel that that's really fast. But what about 1 second? You kind of notice the delay, but you know, we kind of deal with it. We all understand that that 1 second is normal. But what about 10 seconds? Did I turn off the oven? Right? Do I have to pay? Did I remember to pay the bills? You know, you start forgetting. That's 10 seconds, right? You start worrying about everything else. So like you lose the focus if something takes 10 seconds. What's interesting about this study is it was run in 1993. Okay, and so in 1993, when we used the internet, does anyone remember Mosaic? No? Was anyone else surfing the internet in 1993? Oh, man. All right. The other interesting thing about surfing in 1993 is we were using a 28.8 modem, right? So like the internet was slow, and 10 seconds was too much. So you might argue that really 10 seconds isn't really legit. It's probably 3 to 5 seconds. Now, interestingly, the 100 milliseconds isn't accurate either. It's actually 65 milliseconds, and it was actually a range, and that sort of makes sense, right? Different people perceive this differently. And if you play a lot of video games and stuff, you expect it to be a lot faster. It's interesting. If you don't play as many video games, it's slower. It's kind of, this study was really interesting. And what's really interesting about this study is that it was published last night, right? So this is changing really, really rapidly. So this was published yesterday. And so that's the URL if you're interested. Rapidly changing field, guys. Rapidly changing field. So other performance things. Google found that a 3-second delay on a mobile website causes you to lose 50% of your customers. A half a second delay increases frustration. It lowers engagement. Amazon and Walmart independently, about 20 years ago, found out that every 100 milliseconds causes them to lose 1% of their revenue. And then my favorite stat of all is 4% of mobile users admit to throwing their phones. right? So we all know, we understand that slow is a problem. So how do we test for it? How do we understand what slow is, and how do we find that in our applications? Well, the first thing we're going to do is we're going to benchmark where we are today. I'm just assuming we all have a mobile app already, and we need to see where we are today. And then, of course, we're going to input that into our application life cycle. We're going to identify the fixes. We're going to make the optimizations, test it, launch the fixes. But then I think this is an ongoing cycle. It's something you can't forget. You just don't do this once and forget it, because you're constantly adding content to your mobile application. You're constantly adding latency and slowdowns. And so you have to thing that you need to worry about. The tools that I typically use for this are Charles Proxy. For web pages, I use Web Page Test, and Video Optimizer, despite its name, tests iOS and Android apps. I helped build it when I used to work at AT&T. So we'll talk a little bit about the tools and how they work. So the way they work, essentially, is we're looking at the stuff that's being downloaded across. You've got your phone, and we set a proxy in the middle, and we identify all the stuff that's being downloaded, and then we can audit it to see if it's too large or too small. And so Charles Proxy, basically, it looks like this on my Mac, and you get a list of all the connections, you get some information about the headers, and then you can actually see the content. And so then you can look through everything that was downloaded and see if it's optimized or not. And we'll talk about what optimize means and how we can optimize it as we go through page test before. All right, if you're looking at the mobile web, this is an awesome tool. You just type in the URL, you type in a test location so you can test your website anywhere in the world. So you can see what it looks like in Singapore, in the United States, in London, whatever. In Virginia, they actually have real Android and iOS devices. So you can actually test the website on real devices, which is cool. And you get a thing that looks like this. You get all sorts of timings with numbers. You get a waterfall chart that shows everything that was downloaded on the web page. And so you can audit this and figure out what's causing delays on your web page. And finally, Video Optimizer. You plug in your phone, and you pick your collector type, you set up all these settings, you run it, and you get a thing like this. And what we're seeing here is we're seeing the throughput of all the data coming through. We're seeing the packets. So you can see where there's a lot of data, the throughput is high. Where there's not a lot of data, the throughput is low. And then you can also see all of the connections here, kind of like Charles Proxy. What differentiates Video Optimizer from Charles Proxy is then there's a further analysis against 40 best practices. So the idea here is if you have a green check mark there, you're good. If you have a red X, it will show you how to make those optimizations. For example, here's one of the failures on resizing images. These images are 800K, 600. All right, we're back and rolling. Hopefully we'll have that straightened out. So we can with these best practices, it actually identifies the assets that can go back and optimize so that they download faster and it makes your application appear faster. Tools that we're going to use. So we know we have an idea of what we need to do for fast. We have some ideas, some tools. So now we can start testing. And so there are a couple things I'd like to point out here. When you test in your office, if you're connected to a really fast 4G connection or you're connected to Wi-Fi, that's really awesome. It makes for really fast testing. Unfortunately, are not connected to really fast Wi-Fi or to really fast 4G connections, right? They may be out on top of a mountain and holding their, where's the signal, right? We've all been there, right? Is it just me? All right. And you can look and you can see Russia on this one. This is showing 4G availability and the speed. Russia is somewhere about 15 megabits per second, 70% availability. America is about the same place. And charts like these are really interesting, but then you see like I was in Ireland earlier this summer and I had 4G connection, but I had 0 bars, right? Like I've got 4G availability, but like am I going to be able to download anything? Like I was trying to get directions from the airport to where I needed to go and it wouldn't work. So connections are always variable, and they'll probably change during the day, right? If you're testing in the morning before everyone gets into the office, the network's fast. But then you're testing later in the day when everybody's in the office and on the Wi-Fi, it's different. All of the tools I talked about allow you to slow down the speed. So you can standardize your connection. So you can connect to the Wi-Fi, but then slow down the network speed, throttle it to 3G. So you're always testing on a 3G connection. And what that does is it lets you test maybe a little slower, but if it's fast on a slow connection, guess what? It's really fast on a fast connection. So you're taking care of more of your customers this way. It used to be at Facebook, they had 2G Tuesdays where they just cranked down the Wi-Fi to 2G. So everyone had to see what the app looked like on 2G. The next thing I'd like to point out here is that this person is testing on a fairly new iOS device. And if you look at the most popular phones in Russia, like, yeah, they're all iPhones, except for one Samsung. But there's some really old iPhones on that list too, right? Some of the most popular phones here in Russia are pretty old phones. And what's interesting is research has shown that older phones, guess what? They've got older processors, older OS, and they're slower. And so year over year, this research found that websites 20 to 50% faster on newer hardware. So if you're testing on the latest device on a really fast Wi-Fi connection, you're not seeing what your customers are probably seeing. So test on an older phone. If you're testing on Android, I'd suggest getting a lot of people suggest like the Motorola G4. I built this slide when I was in Portugal, so they're all in euros, but you know, about 100 euros. A lot of people are talking now about Android Go, which are these new phones that are coming out. They all run Go, which is running on Oreo, but they're really, really low powered, like 500 megabytes of RAM and like these ancient processors and really tiny screens, and they're deathly, deathly slow. Like all the reviews are like, you get great battery life because you don't want to use it. Right, and they're really cheap. Like that one's the most expensive at about 100 euros. You can find them for like 50 euros you know, like they're super cheap phones. And actually Russia is one of the top markets for these types of devices. So they're gonna be very popular here. The States is also a very popular place for them. So you should test on slower networks. You should test on a lower, older phone, lower range, mid-range phone, not on the phone that's in our pockets, because generally, people in tech have really nice phones in their pockets, and they're really fast, and they're really fun, but that's not what our customers have. So we need to be able to test on devices that our customers are using. So that kind of brings us back to what's fast. What are the metrics we want to use when we're testing to see if the site is fast? On the web, there are a bunch of metrics like time to first paint, time to the hero image, and the speed index. So what do these metrics mean? So this is from Web Page Test, and Web Page Test takes pictures and makes a timeline of what the screen looks like. And so this is my web page. This is my page loading on a mobile device. And time to first paint is here at 6 seconds, the first thing that's painted on the screen. Now, in this case, I would say time to first paint is pretty useless because all it is a blue oval and a gray box, right? That's not useful for a customer. That's not very helpful. Time to hero image here would be at about 8.5 seconds, right? It's got a picture of this loaded. That's probably a little too far, right? I would say that in Web Page Test, it says the speed index is 7.5 seconds. And if you look at about 7.5 seconds, all of the text is there. So that's probably reasonable. Like the page is useful for people to use, right? The information you want is there. So we've all these load metrics. Your mileage may vary. You have to find the right metric that will work for the test you're looking at. What's the right speed for the load time? If you're interested in learning about all the load metrics, these are just 3. There was a great talk given by Paul Irish last month on metrics and measurements, and he talks about all these different things, and it's a great YouTube video. I'd recommend that you watch it. So we've got all these metrics, but how do we know if it's fast enough? Let's say we're building an app for the orange car company, and we've picked our metric. It loads in 6 seconds. That's awesome. Is that fast enough? How do you know? A common way people do this is you test your site against the green car company, right? Well, we're slower than the green car company. And what about the blue car company, right? So how do we know how fast we should be? Well, in general, you want to be faster than the competition, because if you're slower than the competition, people will slide over to them and may buy their car from the other company. So what if you felt like you could beat the green one, but you know, the blue car company, that's the guy who runs that company shoots his cars out into space, and he's a billionaire, and you know, we just don't have the budget to beat those guys. So maybe we just want to tie them. But we can definitely beat the green car company. But wouldn't it be really cool if we could beat the guy who shoots his car out in space? That'd be really awesome. So we maybe set a goal to try to beat it, like an extension. So what are we going to do now to speed up our application? What are the different properties we can look at in our application to speed things up? And in general, the rules for speed when you're downloading content from the internet is to optimize the delivery and then to optimize the content. And we'll walk through all of these through the talk here. The first thing I want to talk about is optimizing the location of the content. So has anyone here heard of cryptojacking? So cryptojacking is this idea where people put JavaScript into a web page, and then anyone who loads the web page is mining cryptocurrency on their computer. And if you do that, like your laptop gets super hot and the CPU jacks up to 100%, and then the person who injected that script makes like a billionth of a penny. But there's a website that does this, and they have one server, and it's in Germany, and you can measure the round trip time to that server, and it takes 10 milliseconds from Germany. But if you're in the United States or you're in Singapore, we're talking 150 milliseconds for every round trip, just to get the content back and forth. Like the speed of light is fast, but when you go halfway around the world, it actually has a latency that you have to worry about. And so if you can get the content closer to where your customers are, you can remove this every single time data is transferred, 150 milliseconds on every transfer. A common way to do this is to use a content delivery network or a CDN. This is a sample one. They have different, they call them POPs all around the world. So for example, if your content is here in Russia, it would probably be served from Amsterdam, from this one, I guess. If your customers are in America, it'll come from Seattle or New York or wherever. So it's optimized. The content doesn't have to travel as far, and it gets there faster. If we look at this sample web page that I built, you can see the time to first byte and the content download. It's 350 milliseconds. And then if we look at the response, we can see it's coming from Fastly. And Fastly is a CDN. So we know this is coming from a CDN. And it actually was a hit. So it hit the cache at Fastly. So it was stored at a server nearby. It didn't have to travel halfway around the world for that content to get delivered. And this is from web page tests. So you get all this information from web page tests. You get it from all of them. It's in the headers of the content that's been delivered. Another thing we can look at is the number of redirects. And I'll show you an example of a web page that had a lot of redirects. I've also seen this in native applications. And so what a redirect is I was actually testing Webpack's homepage. And Webpack's homepage it's a really cool homepage. When you scroll down to the bottom, it has the picture of every single backer, which ends up being a lot of requests for a lot of images, as you might imagine. And I was testing this web page, and what it was doing is it was requesting an image, and then the website was saying, no, we've moved the image, it's somewhere else, times 600 images. So instead of 600 requests for images, there were 1,200. 600 saying, no, we moved it, and then 600 downloading the image. That adds latency for the stuff to download. So started looking around what's going on here. Oh, we can see it. I couldn't even fit them all on the screen, and that's not even all of them. So the yellow lines are redirects. So there's 650 redirects. So I wanted to see how long has this been around. There's a tool called the HTTP archive. And it tracks 1.2 million websites every 2 weeks. And so I was able to see that this is times 0, time 2 weeks later, times 2 weeks later. For about a month, there were 600 redirects, 650 redirects. But it started, and I could actually pinpoint the 2-week time when this occurred. So I was able to pinpoint the time when it occurred. Their website is all open source. So I was able to find the request to the API that downloads all the images. And it's the Open Collective. It's another open source project. So I went to there, and I filed a bug, because I was able to find the actual release where this happened, where they changed where they were pointing to the images, and it happened. Filed a bug. They fixed it. And now if you look at the web page, there's still 600 requests for images, which is a lot. But we got rid of the 600 yellow lines with the redirects. So we've sped up the delivery of the content to this web page. So if your app is ever changing the API, you should probably test all the downstream effects. So in this case, this one company changed their API, and it probably broke a whole bunch of websites that were using it to download the images. I found it on one of them. It was probably on a number of them. So you should always test those downstream effects. But then also, if you see these things, you can file bugs and get them resolved pretty quickly, which is also really awesome. Another issue that I've seen in a lot of native applications is the number of connections your application makes to a server. Is Pokemon Go a big thing here, or was it 2 years ago? Yeah, all right. Big Pokemon, any Pokemon Go players in the room? I see a couple hands, awesome. So remember when it came out, you used to get things like this, like error, or it would crash all the time? Still happens. All right. Yeah, so, I went to Pokemon Go Fest and it was a disaster because the app kept crashing. So when this was happening, I was working at AT&T, and AT&T was like, oh my gosh, is it the network? Is it the app? What's going on? And everybody was blaming the carriers. So I tested this. And when the app is running, there are a couple things you want to see here. One is the GPS is on the whole time, right? It needs to know where you are. You can also see it's pretty chatty. There are a lot of packets going back and forth. And you can also watch the battery, right? Because the GPS is on, the radio's on, the screen is on, right? You're draining the battery really, really quickly. But if we pull out all the other data, all the stuff to Google Maps and all the other things, we can just look at the API calls to Niantic Labs, which is the company that builds Pokemon Go. And what we can see is that it's still pretty chatty. Like, this is simulating the radio, and the radio never turns off because it's constantly sending small little packets of data up to the server. And if we look, there are a whole bunch of different connections to Niantic Labs. In fact, I see 4 right here. And so connection blue is connecting there, connection orange is there, connection yellow is there, and connection gray is there. And then there was one more that was green that I couldn't find over here, right? So there's 5 connections from each phone to the server. So if you have capacity for 100,000 connections, that's not 100,000 users, it's 20,000 users. And so what was happening is you've got all these IPs, every single phone is opening up 5 connections, all the IPs and ports are colliding, and you're essentially having a sort of a distributed denial of service attack just from your application. And this has happened in numerous apps. I've seen it in a lot of different applications where you open a lot of connections rather than just reusing one connection to send those API calls off to the server. So if you can reuse those connections, you can prevent these sort of distributed denial of service-like conditions. and this is not unique to Pokemon Go, but this is just one of the applications where it has happened. So if you're looking at an application and you see when you're testing your application, you see lots of connections that are all remain open to the same endpoint, that's an indication that if you have a lot of users, you could get into this sort of runtime issue. It's not something you'd ever see in testing unless you're doing a lot of load testing. The next thing we want to do is we want to optimize the content that we're downloading. So we'll start first with text files. And so oftentimes when you're starting up an app, you get a splash screen, it's downloading stuff, what's going on. You're downloading some JSON, and that JSON has all the information about what's going to go. Like, here's a list of news articles, right? And inside that, it has links to the images that are going to appear. It's going to have all the text. Everything that needs to go on the screen is in this JSON file. So the faster you get that JSON file to the phone, the faster the screen populates. So let's get it there quickly. So we look at the request headers, and the phone says, hey, I support gzip, which is compression, text compression. And then you get the response from the server, and in this case, I don't see content encoding. This file was not gzipped down to the phone. And so I really want to see content encoding. I also want to see that the file is going to be cached. And we'll talk about that, why we want to see these 2 headers coming down from the server. Let's start with content encoding. That JSON file that populates the screen, right? You've got the splash screen where you're waiting for the JSON so we can parse the data. It's 260 kilobytes. Not a big deal on a fast connection, but it could be a big deal on a slower connection. And the faster you get that there, the faster you can start knowing the images and all the other things that appear on the screen. By simply turning on gzip on your server, that file's now 42 kilobytes, which is 85% smaller. That's going to download super fast. If it's a fairly static piece of content, you can use Brotli compression, and you'll squeeze out another 5%. You'll get it down to 30 kilobytes. When you're talking about another 12 kilobytes, that might be an additional round trip. It's going to get downloaded a couple hundred milliseconds faster, which means the images will be downloaded a couple hundred milliseconds faster, and the screen will show up a couple of hundred milliseconds faster. Really, really worth it. The other header that was missing here is cache control. So why do we want a cache control header? So let's say we have the app. Now we have all the content here. We're still waiting for the images, right? But we have the titles and the articles. But then we read an article and we go back. If that file isn't cached, guess what? We download 267 kilobytes again. And then we read article 2 and we go back and we download 267 kilobytes again. Right? You're adding latency and delay when that file hasn't changed, and it could just be sitting on your phone. So if you just cache it for 5 minutes, you set a max age of 300 seconds, If it's something that changes every 5 minutes, like if it's, and so this will depend on the type of content. Maybe you only want 1 minute, maybe you want 5 minutes, maybe you can do an hour, depending on the type of content that you're doing. But cache it so that you're not downloading the same file, right? Original file, you can see it's the same file, 26 seconds, 56 seconds, like it was downloaded a bunch of times. This is from Video Optimizer, showing that this file was downloaded a bunch of times. The other things, you start thinking about people's data plans, and that ends up being a whole lot. If I brought my SIM and I was roaming on my SIM here in Russia, it's 10 euros a megabyte. So this would have cost me an additional 10 euros to use this app just from the JSON files being downloaded over and over and over again. The next thing we can do is we can actually look at the files that are being downloaded. So this is a different app. The request for the file, the response is 35 kilobytes, but it was not gzipped. If we gzip it, it's 6 kilobytes. This is from a movie application. And so we can start looking at the JSON that's there, right? So we've got Newt. This is from the latest Harry Potter movie, right? We can see Johnny Depp was in this. We can see the image to download the picture of Johnny Depp, right? We can see the screenwriter was J.K. Rowling, as we all know. And then we can start, it keeps going, right? It shows all the producers and everything. And then we can find out about the art directors, the 3 art directors, the 6 art directors, the 9 art directors, the 11 art directors, right? I can imagine like the star of the movie is important, the screenwriter, because J.K. Rowling, that's important, but images of the 11 art directors, I mean, it's not a lot, but you save an additional kilobyte by stripping that out. And when you start talking about speed, if you can make it 20% smaller, that's pretty worthwhile. So start looking at the content that's actually in those files that you're downloading, and if you can strip them out, strip out the stuff that you're not using. This is a fairly small example. I've seen ones that were repeating content over and over and over again. There was hundreds of kilobytes of extra data. Images make up a huge amount of content on native apps, right? A picture says 1,000 words. We have lots of images, and we can make images smaller in ways that people won't see a difference. So if we look back to web page test when we were looking at Webpack, there's this image analysis. And when I do that, it runs a test through a tool called Cloudinary. And it says that there's 1.7 megabytes of images on this web page, but doing simple optimizations would get it down to under 200 kilobytes, right? Pulling off 1.5 megabytes of content is going to cause this page to download way faster. It would save me 15 euros if I was roaming here in Russia, right? I mean, these are all things that we should consider for optimizing our content. Also notice that there are 300 images analyzed. That's a lot of images. So what are we talking about when we talk about images? Here's a response from Video Optimizer, where we're resizing images for video, right? Again, 800 kilobyte image, 680 kilobyte, 1.1 megabyte. These are really large images showing up on a screen that maybe you don't need that much data. The second thing about downloading really large images is, let's say we're on a fast connection, so 2.3 megabytes, even though it costs me 23 euros, isn't going to be that much. It'll download really fast. But on a mobile device, you may not need 16 million pixels. You probably can't even fit that on the screen. So that your CPU then has to fire up and resize it and throw away 15 million of those pixels, right? So you've just wasted that download because they don't even show up on the screen anyway. So you should optimize it so it fits on the screen. If we start looking at the timing here, you can actually figure out, when I do this on desktop, when I do it on a Moto G4, when I do it on one of those Android Go phones, they take about 14 seconds to download that image on a 3G connection. But then to image decode, right, less than 100 milliseconds, 200 milliseconds, 800 milliseconds to decode that image on this device. Because it's a very small screen, it had to throw away more pixels. It also has a very slow processor. So we just added another almost 3/4 of a second to get it on the screen after the file downloaded. So optimizing the images really speeds up the delivery of that content. So here's an image of Portugal, right? It's 2.23 megabytes, it's 16 megapixels. If we just make it 1,400 pixels wide, I've made it 10% the size. And no one can really tell a difference on most phones as long as it fits. I use a tool called Cloudinary, where I just put the width in there and it automatically resizes the image for me. It's a really quick and easy way to do that. The next thing we can look at is to optimize or to compress the images. So you can remove pixels. And obviously when you remove pixels, you're lowering the quality of the image. But in general, you can lower the quality in a way that the human eye can't tell a difference. So there are pixels that are getting thrown out anyway. So if the human eye can't tell a difference, what does it matter? And so this is Video Optimizer, image compression. Here's an image, originally 360. If I save it at 85%, it's 300. So I saved 60 kilobytes. Google recommends that you save everything on the web and in apps you serve at 85% quality. And so if I save this at 85% quality, you can't tell a difference. Another thing that you can do is you can actually go a little further. You can use a structural similarity. And what that does is it takes the quality down to where the human eye, to the threshold of human eye perception. So it lowers the quality even a little more than 85. 85 is just kind of like you throw a dart at the wall and it works for most applications. Structural similarity will go even a little further. And you can't tell a difference, right? The image is exactly the same. And when I do that, I shave off another 40 kilobytes. So this image is going to download even faster. The next thing I'm going to talk about is the different image formats. So these are all JPEGs so far. There are a lot of different image formats out there. WebP is another format that's for Android. If you're doing iOS, there's JPEG 2000. They have similar compression thresholds. JPEG as an image format is 26 years old. So I showed Mosaic, so I already know that 26 years is ancient history. But it's an old format. And so WebP and JPEG 2000 are much more modern. They have better algorithms for their compression, and you save 60% here. WebP on the web is pretty well supported now. It's in most of the modern browsers. JPEG 2000 gets you the other ones. And then same for iOS and Android apps. And when I do JPEG 2000, I squeeze out another 20 kilobytes. Image is unchanged. You can't tell a difference. It still looks great to your end customer. So then you start seeing things like this, where you have little thumbnails of actors down here on the same idea, right? It's that it lists all the actors. You have the image. You can download the image, and then you put it on the screen. And then you're downloading images that are this big and look this good to fit on there, right? And so as an example, if I resize this 363 kilobyte image to something that's reasonably sized, I saved 98% of the data. And this is in production. This is live. I just found this app and I was testing it. So this happens with a lot of different applications, but if you start looking for this in your app, you can find these issues and work to resolve them so that things download a lot faster. And that's how I built it into a circle and optimized it. The last thing I want to talk about here is how to optimize video. Video is a huge thing, streaming video. People are talking about how it's going to be 75% of all network content in the next 2 or 3 years. And it's pretty easy to optimize it once you know what you're looking for. So here is an example test where I ran with web page test. I was testing a website. It has a lot of video. And you can see fully loaded was 263 megabytes to download this web page. And web page test puts a little $sign right there, but you start thinking that this would cost me over 2,000 euros to download here on my roaming plan. And that gets really, really, my kids ask me, Dad, why are we eating rice again? Because I got my cell phone bill. So what's going on here? Well, we can look at the waterfall of this thing, and we can see some pretty big video files are downloading. Video files are in green in web page test, and they're really big, so they stick out, right? Because it takes a long time to download video files. And so, it's a web page. It's at the University of Illinois. It's got this video playing in the background. It's really awesome. You can find the video tag. And so the first thing we want to see is preload equals auto. If you have this on a web page, it'll automatically download the video whether or not you play it. So that can be really good if you know the video is going to get played. But I've seen lots of web pages that download the entire video even though you don't press play, right? So that's kind of wasting. Number one, it's costing your company a lot of money because you're paying for all those server costs to deliver the content. It's also costing your customers money as well. The next thing we see here is autoplay, loop, and muted. So on a mobile, that will, on Chrome, mobile Chrome, that will cause the video to autoplay and to loop. If you wanted to do this in Safari, you should add the plays in line as well. So this actually won't loop on mobile Safari, despite the fact that they want it to. And then it downloads the video when it plays. And we can see that this video on a 3G connection took 47 seconds to download and is 96 megabytes, right? Number one, on a mobile device, that's a huge video. It's a pretty huge video on desktop, too. It's going to take a long time to download. You should optimize the videos so that they're smaller, so they download a lot faster, and we'll talk about that. If I do, this is the URL for the video. I can run a tool called FFprobe. It's part of FFmpeg, and it gives me a lot of information. It tells me that this is a 1080p video, that it's 98 megabytes, and the bit rate is 15 megabits per second. Like, this is a really, really big video to be downloading to a browser. So you should resize it for desktop, and then probably resize it again for mobile to go even smaller. So you can lower the quality, you can lower the bit rate, you can lower the sizing, and all of those things, just like we did for images, we'll do the same thing for video. If I make it, if I just lower the quality to 70, it goes down to 27 megabytes, still big. If I make it 720p or 1080p, it's 4.7 megabytes, right? Same video, same quality, no one will notice a difference, but 4.7 megabytes, it'll download versus 98 megabytes, right? Your customers will see it, so that's pretty useful. The other thing that I found is that it has two streams. It's a silent video, but it actually has a silent audio stream that's 2 or 3 megabytes, so you can remove that and save even more data. If you're interested in a lot of best practices on how to optimize video, I wrote an article with like 15 best practices. I don't have time to go through all of them today, so there's a link to the article so you can read that. One more thing about this website where it downloads the video. Down here, it's downloading the exact same video again. So what's going on there? Well, it turns out while I was testing this web page, I found a bug in Chrome. So a lot of times when I'm testing these things, you actually find issues in the browser or you find issues in the operating system. And what's great is these are all open source things, so I filed a bug. And they've actually been able to reproduce it all the way back to Chrome 60, so they're gonna fix it, because obviously. Number one, you shouldn't send 100 megabyte videos down, but if you do, it should probably get cached, and Chrome is not caching 100 megabyte videos for whatever reason. Now you might say, the easiest way to not deal with video is just like, let's just give it to YouTube or Vimeo and let them deal with all of that. There's no initial video download, but on a web page, you can expect 700 to a megabyte of additional JavaScript just to prepare for that to download. So you're gonna add latency just because you have all this other stuff that needs to get downloaded for the video. And then, you know, does anyone here watch TED Talks? Right, TED Talks, they're really awesome, they're great. You can embed TED Talks, right? There's a share link. If you build it on the web, it's just a one line of code, which is super awesome. You know, one line of code, that couldn't cause any problem, right? This is Chrome DevTools, and it's 118 requests and 32 megabytes downloaded for one line of code. It downloads the entire video, whether or not you watch it or not. This is it's adaptive bitrate streaming, so if you're on a slower network connection, it may not be 32 megabytes, but it's still a lot of data. So no matter what, if you integrate a third party into your app or your website, you should probably audit to see what happens. Test it beforehand, test it afterwards, and see what happens, because it could really impact the performance of the load of your page or your app. So the rules for speed: optimize your content delivery, get it close to your customers, reduce the number of connections, reduce the number of redirects, optimize your content. Make it as small as possible. If it's small, it downloads fast, even on a slow connection. If it's fast on a slow connection, it's fast on a fast connection. And so we talked about how to optimize text files, images, and video. And then we can test, and let's just say we tied the blue car company, right? But we have to be careful. We did our initial test, but as time goes on, if we're not careful, we're gonna slow down again. As more and more things get added to our application, to our app, to our website, it's gonna slow down again. So you need to constantly audit, look for things. You can't just do a benchmark once and ignore it. You have to constantly look for performance issues as you're adding new features to your application. There are a lot of tools that will help you do that. This is for websites, it's called Speed Curve, but it just tests your web page every couple days or every couple hours. And you can set warnings. So if you go over this line, send me an alert, right? So I know that we've gotten too slow. You can figure out what the cause is, and then you can fix it. So you can set your failure thresholds and be alerted when things are slowing down. So make this as part of your automated testing, the timing for things to show up. So in conclusion, when things are fast, when it's fast and it loads quickly, your customers are happy. And when your customers are happy, they buy more stuff. And when they buy more stuff, that means your app is successful, right? So test your content for fast delivery. Minimize the size of your text files, of your images, of your video, and then keep an eye on all your third-party content. And then keep testing. Look at it for performance issues, and so you can identify them and get them resolved as quickly as possible. The tools I used, Charles Proxy, web page test, video optimizer, some of the tools that I use to optimize images and video, and then Speed Curve is a tool for monitoring web pages over time. And so with that, thank you very much for listening. I'd be happy to take any questions. Yeah, go ahead.
We have time for questions.
Yeah.
Please.
I just want to ask, do you test native applications on Android and iOS? And what tools do you use?
So the tools that I use when I'm testing the native apps, let's go back. So I didn't show a lot of screenshots from Charles Proxy, but it's a great tool. It runs on your computer, and it works as a proxy. So basically, you connect to the same Wi-Fi connection. All the data goes through your the computer, and you can see the content. Video Optimizer actually runs on your Android or your iOS device, and then the results end up on your computer when you're done testing. So those are the tools I use for testing iOS and Android apps.
Okay, but it's all about network.
Yes.
I'm just asking about native apps and performance.
So these are all things that were downloaded by the native application inside the native application. So these are ways to look for performance bottlenecks on the network for your native applications. There are other tools that I use for testing for other performance things. They're in the book, but I only had an hour to talk. So you feel free to look through it there, and I describe memory leaks and all sorts of other things in there.
Hello. Hi.
Hey.
My name is Vadim. I'm from Tinkoff Bank. Speaking in terms of stock market, if you have lots of data in real time coming to your phone, what would be your suggestion to optimize this process, and how would you test it? Maybe you know some extra tools you would use it for that case.
I think the trick is to try to optimize what's getting delivered. So if they're only interested in 10 stocks, try to only deliver those 10 stocks. I just found a web page last night when I was researching something else that rather than using an online dictionary, they downloaded the whole dictionary in their HTML, right? So if you're downloading the entire Oxford Dictionary in your HTML, like that's way too big if you're doing it over and over and over again. So if you can just limit what's being downloaded, obviously real-time information like that, there's gonna be a lot of it and it's gonna come fast and furious. In some cases, there aren't optimizations for everything, but if you can reduce the amount of content that's being delivered. And maybe you could do notifications, push it, like when they're only in the application. Yeah.
Hi. Can you please expand on your staying vigilant loop when you rerun your benchmark and about the process of integrating it inside your continuous delivery system?
That's a good question. So if you have say you have an automated test for testing login, and you know how long you could just set a timer for when the login is complete, right? So if you know when when the test starts and you know when the test stops, if you start seeing variations in that timing, then you know that something happened, right, during that login or during that load time. So if you had an app that was loading in 5 seconds and all of a sudden it takes 6 seconds or 5.5 seconds, maybe you can look to see what happened over that time to see why that test is taking longer to run. Obviously, there can be blips in the testing, right? There are always other issues that can be there, but if you start seeing your tests running longer, Perhaps you can add in some metrics, like there are ways to, in the app, to say when certain things have fired, when an image has appeared, so then you can start measuring those timings as part of your automated testing as well.
Hello. If you have integration in your website, third-party frames, for example, a frame,
Yes.
is it possible somehow to improve its work, for example?
Right. So
Because you cannot do something with this iframe, for example.
right. So if you have a third party that's causing issues, so I'll just say you have a Facebook something in your app and it's causing things to slow down. There are a couple options. One is you can push to like cut the Facebook thing out, right? That may work, that may not, right? I mean, obviously Facebook is pretty important for different tools, right? Maybe you can't get rid of it. If it's a certain library or something, maybe you can find an alternative that does the same thing that runs faster. Another thing that's been really helpful from other people who look at these sorts of things is you can reach out to them. Just reach out to that third party and say, hey, we noticed that this is running really slowly. What can we do to speed it up? And oftentimes they're not aware that it's slowing things down. And if you can show them that like, hey, if I pull your library out, I'm running a lot faster. Why should I keep my library in there? You know, bluff a little bit, maybe. That's one way to do it. And then I've also seen people name and shame on Twitter. Like if you just @ them on Twitter and say like, when I have your library, it's really, really slow. What can we do? You know?
That's fine, thank you. And one more question, please. As far as I know, Charlie's Proxy is paid software. Do you have some analogs with open source?
Wireshark works really well as well.
Wireshark is... there is a problem with Wireshark if you use mobile. You need to have some Wi-Fi to run...
Same with Charles Proxy. They both have to be on the same Wi-Fi connection, and you have to proxy through your computer to make those to run.
Wireshark, okay. And the last, можно?
Yeah, go ahead.
Where in the beginning of your speech you have an image with the mountains and the bridge. Where is it?
It's in Grindelwald, Switzerland. It's called First Cliff Walk. It's actually really cool if you're not afraid of heights. It's really cool if you are afraid of heights, but just... There's a swing bridge that my older daughter she had to wait until the younger one went away, because it was, when my 6-year-old was on it, it was... Then she went away and then my daughter was able to walk across it.
Пожалуйста, еще вопрос. Ага, вижу.
Hi.
Hi.
I just want to ask you, have you tested requests and responses? I want to ask, in terms of performance, is there any difference between HTTP 1.1 and HTTP 2? Because you know we can shrink, as I know, we can shrink some headers, some additional data.
Right.
That transferring from time to time, and maybe we can save some additional bytes by transferring to this HTTP 2 protocol.
Yeah. Right, and I didn't have time to get to that, and this is still like active research and active debate in the community. So HTTP 1, the idea is you can only send one file at a time. You can only send one file at a time down the pipe. And so what ends up happening is when you're doing HTTP 1, where's my mouse? I lost my mouse. Do it the slow way. When you do HTTP 1, you may have to open a lot of different connections, sort of Pokemon Go. This is going to take forever if I do it this way. Sort of Pokemon Go-ish, right? So Pokemon Go had 4 connections to send that data back and forth. And so you'll see that in the browser where the browser will open 4 connections to download all the images over HTTP 1. HTTP 2 allows you just to use 1 connection, and everything can be downloaded over the same multiplex down the same pipeline. And in general, that's a lot faster. There's still a lot. Every implementation of HTTP 2 on different server are different, and so they handle prioritization differently, and so some of them are a lot faster, some of them are about the same as HTTP 1. So your mileage will vary depending on whether you use... It depends. The classic "it depends" answer. In general, it should be faster, but not all HTTP 2 implementations are the same, and so some of them end up being don't have that much of performance gain.